Okay, one of the things we have to be able to do when we solve equations is we have to be able to handle problems that have fractions throughout. And the way we do that is we actually want to get rid of the fractions. I have a lot of students that might want to turn these into common denominators. If you're really good at fractions, you can handle it that way, but the faster and simpler way is to get rid of the fractions. And the way you do that is you multiply every term by the lowest common multiple. Now, I'm going to take this equation and I'm going to spread it out just a little bit. 1/3 y plus 1/4. I'm leaving a little bit of space so that I can show how to multiply every term. Now, the lowest common multiple, think of it like a common denominator. If I were going to add all these fractions up, the common denominator would be a 12. And the lowest common multiple is a 12. 12 is a multiple of 3, 4, and 12. Those will all go into it evenly. So I'm going to multiply every term by a 12. And what that does is it's going to reduce every one of these denominators. Now 12 goes into 12 one time. So that's a 1, that's a 1, and that leaves me with just 5 times 1, which because we multiply all the stuff that's left. That's just a 5. 4 goes into 12 3 times, and 1 times 3 is 3. And 3 goes into 12 4 times. And the denominators all turned into 1, and that's why we end up clearing the fractions. All that's left here, 4 times 1 times y, which is 4y. And now we have an equation that we can solve. It's just a two-step equation, and we can show 2 steps, 2 operations, inverse operations. Let's get rid of the 4. We'll divide both sides by 4, and we get y is equal to 2/4. We always want to reduce our fractions. We get y as 1/2. Let's take a look at one more fraction problem. After that, I can point you the direction of a different video from 8th grade math, because this is an 8th grade standard to be able to clear fractions in a multi-step equation. You'll notice that only one of these terms is actually written as a fraction, and the easiest way to deal with this in terms of clearing fractions, there's other ways to solve a problem, but if we wanted to do this with clearing fractions is let's actually turn all the terms into a fraction. So I'm just putting a 1 underneath the other 2 terms, and you'll notice that the 3 denominators are now a 1, a 3, and a 1, and I'm going to spread that out. 15 over 1 equals a over 3 minus 2 over 1. And now if I want to clear the fraction, I've got to multiply by the lowest common multiple. Well, the smallest number these will all divide evenly into is a 3. So I'm going to multiply that by a 3. I'm going to multiply that by a 3. And I'll multiply that by a 3. So 3 times 15 is 45. Because the 1 doesn't reduce, there was never a fraction there to begin with. But here there was. That 3 reduces with that 3. They just become 1. And that leaves you with an a, and then minus, and then 2. The 1 and the 3 don't reduce. 2 times 3 is 6. And then we're one step away from an answer. I'm going to turn it around at this point. I'm going to put a on that side. 45 and 6 makes 51. So when not all the terms are a fraction, that's how you clear the fraction. Actually turn them all into fractions and then multiply by the lowest common multiple. In this case, that was a 3. I wanted to take a moment and acknowledge some of these hot questions or these higher order thinking questions. These actually require a little more involvement and a little bit more background knowledge. We talk about these together in class often, but so that you don't get frustrated with a problem, let's take a look at number 25 and let's try and get you going in the right direction. It says one angle of a triangle. Now when I see a triangle and I see I'm being asked about a triangle, a lot of times a simple picture might help, and it doesn't even have to be an accurate picture, but it just has to be a picture that represents the problem. I don't have to pretend that this triangle is the one that they're talking about in the problem. I just made up a triangle. And it says one angle is 120 degrees. Well, that's the number of degrees here. Now 120 is obtuse, which means more than 90. And this doesn't look like it's more than 90, but that's okay. I'm just going to call it 120 degrees anyways, and I'm going to pretend because it doesn't really have any bearing on the problem at all, whether it's accurate drawing. It says the other two angles are congruent, and congruent means equal or the same. That means if this was, say, 50 degrees, this would be the same. It would also be 50 degrees. But since we don't know how many degrees the congruent angles are, we're going to let that be x. So there it is. That's our triangle. And if you remember from, I don't know, 3rd, 4th, 5th grade math, at some point you have learned how many degrees are in a triangle. And you should remember that if I take all three angles in a triangle and add them up, it adds up to 180 degrees. And 180 degrees is equal to the 120 degree angle I know, plus the other two angles, which are also the same. So plus an x plus another x, those are the three angles of the triangle, and they add up to 180 degrees, and that'll allow you to write, that's the equation, that's what it looks like. You can solve it and figure out the measure of both of those two congruent angles. Okay, sometimes we get asked problems that ask us to do things like define a variable, and sometimes they give us 2 or maybe even 3 or 4 quantities, and we don't actually know any of them, and we have to do something called defining one quantity in terms of another. Now this problem is about two people. It's about Maggie's brother, and it's also about Maggie. So there's two people. So one is Maggie, and then one is the brother. And we need to try and read the problem for understanding and see what we're looking for and see how to define both of them. Because it says Maggie's brother is 3 years younger than twice her age. That doesn't really tell me how many years either of them are. But I do know this. I do know that if I take them and I add them together, if I add Maggie plus her brother, I get 24 years. Now there's a lot of ways that I can add something up and get 24. It could be 10 and 14, or 9 and 15, or it could be 20 and 4, or 12 and 12. They could both be the same age. Those would all fit the bill, but I got another set of requirements to meet. It says Maggie's brother is. They're about to tell me about Maggie's brother, so I am going to know something about the brother. And it tells me that the brother is means equals, 3 years younger than twice her age. Since nobody tells me anything about Maggie, Maggie's age, we are going to give it a variable, and I'm going to let it be m. But now that I've called Maggie m, I am going to define the brother in terms of this quantity right here, which is 3 years younger. That's 3 years less than twice her age. That would be twice Maggie's age, but then subtract 3. And I know that if I take those two quantities and add them up, it comes out to 24 years. So hopefully you can take a look and add those up. And there's nothing to add the minus 3 up with, so you should end up with 3m minus 3 equals 24. And that'll allow you to solve for m. When you solve for m, we've got to go answer a couple questions. First of all, m tells me how old Maggie is. And if I take whatever Maggie is and multiply it by 2, and then take away 3, I'll figure out how old the brother is. And if I know both of those, they better add up to 24 years old.